right, so let's get into the meat of this malware in here right now. So I've got IDA open, and we will try to now understand how it is doing stuff in here, right? So first of all, when I loaded this binary into Ghidra, as you can see that there's lots of functions, lots and lots of functions in here. It's crazy. But IDA is very generous. It gave us all these Windows API functions in here, which this binary uses, and we can just use cross-references to find out what exactly it's doing. Lots of topics to cover in this video, so let's get to it very quickly. All right, so first thing we see, very interesting function. It's a bcrypt genRandom function in here. Now, bcrypt genRandom function, let me give you a very brief background of this function. This function is used in the cryptographic library in Windows. What this function has is it actually takes, I think, 3 arguments. First argument is it's the hashing cryptographic algorithm, which is known as H algorithm. Second is a random key, or you can say a random number, and it generates a random number itself. So let's double click on it. So we'll double click on it decompiled, and we hit X to see where it is referencing to. Now I have already seen this function here. That's why I renamed it. So you can understand easily without actually looking for a suitable function which is it's using. Of course, many function is calling the bcrypt genRandom function, but we have to see the most relevant function it uses. So let's go to this function. And as you can see here, it is being set up. A variable v4 here is taking a random number from bcrypt genRandom. Obviously, this function is the returned value of this function is going to be a random number. Is getting in the random key in here from this algorithm it's going to be using. And if this is less than this thing, this hexadecimal value of this thing. So this is maybe it's trying to look if the key is valid or so much that it will do its stuff here. What's interesting to note is when you scroll down here, it goes to a label. It goes to a label in here. You can see it, and it's ending in here. It's got to a label 9. And when we go to label 9 in here, it calls another function in here. Now, this function was returned to this function. It wasn't cha-cha cipher encrypt one. It was just one of these names, sub underscore that name. But the reason I named this function cha-cha, I actually should have gone the opposite way. But yeah, it's actually easy to go through cross-referencing the Windows API function. So if we click on this function in here, it takes us to this function. Let's assume that it's not the cipher encrypt function that we are talking about, because I named it after I knew about what it is. But let's actually go deeper in this function. Scrolling down, there's a lot to scroll by. We see this amazing kind of things in here. Expand 32-byte K. The reason it's like this is because it's pushed in stack, and stack is a LIFO structure, so you get it. Now, expand 32-byte K is a very interesting string because it's a cha-cha 20 cipher. The first, I don't know much about the specifics of it, but it's a cipher stream. And yeah, I've actually written as a comment in here, it's input include a 256-bit key, a 32-bit counter, 96-bit nonce, all of that stuff you can read it in the internet. The main takeaway from this is that cha-cha 20 cipher, the first string it has is this expand 32-byte K string. Now, its initial state is a 4x4 matrix of 32 words. The first row is a constant string expand 32-byte K, which is cut into 4 into 32-bit words. So I don't want to go deep into how this algorithm works because that's going to be a part of cryptography. We're here in reverse engineering malware, so we're trying to understand what this malware is trying to use, what kind of cipher it is trying to use in here. So expand 32-byte K surely means that we are trying cha-cha 20 cipher in here, and it's proven that we are using that this malware is trying to use a cha-cha 20 cipher. Now, as you can see, lots of stuff is going on in here, but we found a major hit that this malware is using this kind of cipher. Now, wait a minute here, because this isn't the end exactly, because there's very interesting thing going on. if you go to Keydraw and search for strings here, I'm using Keydraw to search for strings in. If you type in char20, it will give you the cargo, like I've seen it said in the previous video, cargo package manager and all this. It will give you a Rust binary at the end. If you can see it, it's called sse2.rs. Now, if you search for sse2.rs, you'll get a strange reference to AES. Now, AES is also an encryption procedure, as you probably know. So that actually motivated me to search for AES here. And oh, we have something with AES. That's interesting. If we hold our mouse here, we can see that ctr.rs. ctr.rs is, if I'm not wrong, is an implementation in Rust about the AES. And so maybe this malware is also using AES, because I've seen AES in here. Because if it is here, it must be using this, or otherwise there should be .aes. So there's actually two cipher streams, two cipher methods this malware is trying to use. First is the cha-cha-20 here, which we've just seen, and AES. Now, you may ask why two, why not one? Well, because in AES encryption, sometimes the hardware has some acceleration. Hardware supports AES encryption for faster encrypting the files. So maybe it's searching for that kind of stuff in your system, that, hey, if there is hardware acceleration stuff, if there is some kind of hardware compatibility that I can use this, I will probably go for AES because it is very faster. But if it's not the case, then let me use cha-cha-20. That's the way it's trying to choose between the kind of encryption method it's going to use. Very interesting stuff indeed. So one thing down is that we have the, what is it? Yeah, we have the default cipher mode in here. We have the default. Now we have the cipher. We have the cipher encryption. So we know that this my malware is using cha-cha-20 or AES to encrypt all the files in here. In some cases, I've seen that it uses Salsa. I've read some very short synopsis of this malware in the internet. It says it's using Salsa. So yeah, but the AES is constant. It's using AES in all of its variations. So interesting to note that. The next thing in our checklist is kill services and kill processes. We'll start by going to kill services portion. Now, again, we're going to go here and we're going to see kill services. That means it's trying to kill the service. The relevant API for that is control service. Let's see if you can find that in here. Sure enough, we find it. Double click on it. Select it, cross-reference. I've already named it as shutdown services, so it doesn't get lost between all this function names. Yeah. Now, it's very interesting function, as you probably, if I scroll a bit up, you can probably see here, I think, or I think it's not in this function. All right, I'll just show you guys after this one. So basically, control service v3u 1u, so it's passed all these parameters in here. And it's saying the 8 service, and the handle of the service is trying to use the control type LP service status. Now, the second parameter, as you see, DT of the control here is 1. That means service stop. This is directly from the Windows API documentation, MSDN. I'm not saying it myself. You can go ahead and check it. Control service, the second argument, 10x00000001 means that, was that 7 zeros or 8? I don't know. Well, you get it. 0x 7 zeros, then 1. So the second parameter, sorry, 1 means that this means service stop. So it's controlling all, so it's stopping all the services just like that. And it's probably interesting. So yeah, you know the service is stopping like that. The thing that I've tried to show you before, I'm trying to show you, it also has the open service W, open SC manager, and all this very API calls from here. So I think it also has the, let me look at this query service status. Let's go to this one. So cross-reference to this one, it is in the shutdown services. So first off, it's querying the services. It's saying as a status info and all of these things. Now, this is after our control services here. Our control service was here, and then it's this function is after. I've lost it. No, I didn't. Query services. So it's when it's stopping that, it's querying the services that if anything is still running, if it's anything, it's um, querying the whole services stack and so on. Then OpenSC Manager. This OpenSC Manager is this function, this whole function where this API is responsible for in charge of services. Okay, it's enuming the services status. As you can see here, it's enumerating everything, and Open Service Manager service OpenSC Manager W. Getting all the services, I presume, and then slowly terminating them using control services in another function. Pretty interesting in how it does that. I can probably visualize a C program where it can where it's likely to do this kind of thing, but again, I don't have much experience in Rust programming language, so I don't know. I'm just reverse engineering this stuff. It's just a pseudocode to understand what it really does. So this is this function is probably it's in charge of the services. So there's two functions here to recap. One function is enuming all the services that we have here, and the second one is just control service, close everything, that kind of thing here. It also has enum dependent services, which is a very interesting call here. And if we go to the cross-reference in here, it is referenced in shutdown services here again. Now, enum dependent services, I don't really remember the definition of this, but I think it's one of the child process of the service. May be wrong, but you get the idea. It's all related to shutting down the services. As soon as I see control service in here, I get the idea what is actually going on in here. Now let's talk about processes, because it's killing our processes too. Where is it? Here. It's killing our processes too. Now, the thing about processes is it's slightly different from services because it uses, let me just go here and find the relevant function so we can talk about it. And the relevant function for processes is, let me just look at here. Or let me just try to snap. Yeah. Create tool help 32 snapshot. Click on that. Go to cross references. Go here. Now, there's a lot of things to discuss in here, so let's jump in. Create tool help 32 snapshot is from the header file tl help32.h, which I think currently it's not being used because it doesn't work in Windows. I think it does work. Don't know. I'm not updated on that documentation stuff. But create tool help 32 snapshot is basically what it does. It creates a snapshot of all the processes running in your PC right there. And when you get the whole snapshot, when you get the whole process list, essentially list from that, from the snapshot, then you can enumerate those stuff, process 32 first W. By the way, you cannot just use process 32 first W function. You have to use a DW size here. So that's why it's using p.dw size. This is very accurate. Now, this is typical malware behavior. Why do I say that? Because in DLL injection, let's take an example of DLL injection, okay? Now, when you're trying to do DLL injection, the base thing about DLL injection is like you have to open a process, create a virtual space there, use load library A, stuff like that. But how would you get the process ID of your process that you are trying to inject the DLL into? Well, we use this algorithm. Yeah, it's a very short algorithm that we create a snapshot. We find the process ID from those processes that is in the snapshot in here. It's similar here. It uses the process 32 first here. And as you can see, tool help 32 snapshot. It's trying to loop over all these kind of things. And as you can see, there's process 32 next also. So you know that it is kind of enumerating all the services and so on. And at the very end of this, we have the terminate process here. So we have this terminate process in here. At the very end, not very at some point in between, we have terminate process in here. So we know how it's deleting the process. Now it's crystal clear. Getting the snapshot, enumerating all services, trying to terminate them one by one by one by one. Now it's we all know that it's deleting this process and services so that it does not interfere with its cryptographic activities that it's doing here. I don't want to get off track, but if you look in here, it also does a vssadmin.exe delete shadows. So it's issuing a direct command to the PC that if that is using vssadmin to delete the shadow copies. As I've said before, shadow copies is where the backup is getting stored. If you're deleting those backups, then there is no way that you can ever recover anything. So shadow copies might have your information, might have some kind of backup information. It might have some volume backups also. So it's deleting those, remove all. Yeah. So it's deleting the shadow copies, as we know that. The next thing that I'd like to show is let me just try to search for it here. Something to do with process token. Yes, this thing. Now this function is important. Why is it important? Because if we go here, token, open process token. Yes, go to X references, double click this, here we go. Now this open process token is a very interesting Windows API. Of course, all APIs, of course, is interesting when in a malware, but this is particularly interesting because it is querying about the token that a process is using. Now, to be honest, token is Windows, when talking about security in a Windows system, token is something that the Windows PC that Windows maintains, right? Like when you are trying to just run a program, just run Notepad, okay, you get two options, right? You can open it by your current context, or you can open it as administrator. Now, when you open it as an administrator, a smart screen pops up saying that do you really want to open it as administrator, or you want to make this app make changes, something like that. So then your security token suddenly gets changed to the administrator, right? And open process token is exactly querying that. It's saying that what kind of security levels that you want to open this process as. So if so suppose the malware gets its privilege escalated, it can use this to get to query these processes, which is using a higher token, which is running as administrators and so on, probably perform malicious activities with them. It's also, as you can see, it's also get user profile directory. It's getting into there with the H token that it found in earlier in this one with the token handle. As you can see, how the flow is going here. Current process is getting into get current process. So it's probably is kind of looping through this thing, querying every process like that. And the result is stored here, which is it's getting the process token in here, and then it's getting the H token. It's getting this into the H token thing, the token handle here, and then it's passing through to get user profile directory. So yeah, doing a lot more stuff in here. So this is about how it is doing things with services and processes. The next thing to take a look at is probably the volume information. So volume information is interesting because volume information is the fact that the malware is looking for other volumes, other memory volumes in your PC so that it can encrypt those things as well. It's looking for those stuff, essentially. So that's why it's using find volume close, find next volume, and find first volume. We're gonna go and look into this one by one. And as you can see, it's in this thing. So we'll double click this and we have here. Now it's using find first volume, find volume. And if we get volume path names for volume name, this is a very interesting API. It's using the first thing as LSP is the volume name, the volume path name, and the return as Ida, is very generously showing us this thing because of the Windows API here. So it's getting the information for other volumes. For other volumes, if it finds other volumes, it's going to go there and it's going to encrypt any information or any file we have here. And it's going to do that. It's getting the volume name, it's getting the volume path as we have just seen here. And I can show you that again. Here, get volume path names or volume name. If you hover over this one, it will give you the volume path names. So we know that this malware is trying to do very malicious stuff with our memory volumes as well. So next thing is obviously the NetShareEnum. We have seen here that it is in the options, it says that no prop servers. So that means it's making network discovery, something network discovery. And to our very fortunate, we have NetShareEnum API call being used in here. So let's go here and see where the NetShareEnum API is used. And we have here. So NetShareEnum API is used in here. If we hover over this, we can see it. We have the server name, we have level name, we have entries, read, total entries, and resume handle. I mean, if you have ever used SMB client or SMB map, you probably know what it's trying to do here. It's probably going to list out all the network shares the PC has, the infected system has. And we probably know what's going to happen next. It's going to use PSExec and try to authorize login on those shares, on those network shares, or trying to just, anonymous login to see what's in there and trying to encrypt stuff there as well. So this is the network discovery stuff that we're talking about, NetShareEnum and NetServerEnum. It also has NetServerEnum. So you click on that, cross-reference. And this is not in our discovery portion. So on to our next section, which is system info. Now, system info is pretty interesting in this malware because it's you probably have seen here it's getting some virtual machine on ESI, and also in the very last it's saying enable ESXi VM kill. So something to do with virtual machines as a whole thing. Now, VMs, the virtualization technology is obviously it's different, right? If you run some programs, if you are trying to get some system information about some hardware information, it is going to be different from where if you're running that application in querying that information in your host computer versus the one that is in your virtual machine, right? So what this malware does is it's actually seeing that if it's running in a virtual machine or not. So it's getting wait, hold on. Processors, I think, is the name in here. Oh. Okay, we'll just go with the sysinfo one, or just look it up in this table. To show you guys that. Let me see. Query performance, frequencer, performance counter. Let me just try to find it for you guys here, and we will be all right. I can't find it here, I think. Okay, well, we will just try to yeah, we'll probably see it. So let me go to sysinfo because this function has all this. I'm just going to try to reference that to exactly point out that location which I was talking about. But let's actually go through here. So sysinfo, this function is very interesting one because Let me just scroll down so you guys can probably see it. Yeah, here it is. Uh, this is interesting stuff because if you scroll down a bit more, it says processor architecture here and allocation granularity. So, I mean, this is very much uh, saying that look, if this is a VM or not. It's trying to see number of processors, active processors mask, LP applications address, lots and lots of stuff. It's getting the system information about processor type also. So why would it do that essentially? Because it has this functionality that is to kill the VMs or to behave differently in a VM. It very happens that it will behave differently when in a virtual machine. You have to go for a dynamic analysis to know what's different if it's being run in a virtual machine or if it's being run in a host machine with bare metal. So it's really interesting. As you can see, it's the total number of processors. In above, we saw many interesting things, and yeah, these are the things that the malware actually did. This is juicy part. So we got to recap. We know now that the cipher of the malware, which is AES or CHA-20, we know how it kills services, kills the processes, getting volume information about what we know, then enumerating network shares, network discovery, and getting information about the system as a whole. So on the next video, we will explore more about how it changes the wallpaper stuff and how it actually changes, how it changes the wallpaper stuff and some other miscellaneous stuff that is maybe interesting to know about in the malware processes. And yeah, I really appreciate you guys watching, and I'll see you guys in the next video.